Eat up. I'm going to class. All right, good afternoon, all. How are we today?
I'm doing all right, sir.
Good afternoon.
Great, 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 great. Everybody all right?
Yes, sir. And how are
Yes,
you?
sir.
Boy, I'm good. It's just that I'm a little tiredish. You know, I had some running up and down to do, including going to the main campus to sort some stuff out. And yeah, but outside of that, I'm not going to complain. I'm good. Yeah, and I really hope that you guys are feeling the same, so that come in another few we can get the ball going. All right. There is a question though that I need to ask of you. How many of you so far are feeling comfortable? Is there anybody in the class that feels totally lost with what is happening? I need for you to speak up and speak honestly. Is there anybody in the class that is totally lost? Don't have a clue what you're dealing with? All right. So when I hear you don't answer me, am I to take it that you guys are fine?
There's somebody in the chat.
Or somebody in the chat? Hold on. I have to switch devices because the rest of you can go on. All right. I'm still here. I'm just trying to connect to another device that I can manipulate the chat a little bit better. Okay, Giovanni, got your message. Tatiana, okay. Okay. All right, so Tatiana, I was not here. Okay, Tatiana, that's not a problem. Hold on, don't answer it. Don't answer me. Let me just switch this thing here. All right. Can you hear me now? I mean, are you still there? I should ask.
Yes, sir.
Okay, all right. So, all right, Tatiana, I'm not worried. I won't tell you, but I'm not worried. I am not worried because you weren't here. So what I'm going to do, Tatiana, is give you an opportunity to go through the recordings. I have a YouTube channel, and all the recordings, as soon as they're made available, I post the YouTube channel. I mean, the recordings to the channel. So I'm going to ask you, Tatiana, to go through, look at, watch the videos. There are what, two videos. I think it's only Saturday. Last week you started, last week Monday.
Yes, sir.
Yes,
Right,
sir.
right. So you just have two videos, Tatiana. So it's really not a whole lot for you to go through. So I'm not going to be concerned. I'm going to give you an opportunity to access those classes asynchronously. Then you come back to me for next class on Friday, all being well, and we can talk about it. Now, this weekend, and in particular yesterday, was spent on, well, from Saturday night. Saturday night I was up, just trying to get some notes in for you guys, and just to do some stuff with you. And I got really, really, really excited. And yesterday I said to myself, no, it's time for me to go and I'm gonna get some rest. And but I really hope that you guys are as excited as I am and are putting in the work. You guys would have gone through Unit 1 already and will recognize the level of work so required in order for you to reap the success. So I'm going to ask you, please, even if you read, not read, but even if you watch the recording one time, okay. So I'm just recognizing now, so I have two Tatiana in the class. One spelled like foreign and one spelled like Jamaica. All right, so, and then now two Chanel in the class. Well, Chanel and Chanel. Nathalie, Nathania, Natalia. Kisana, Kisiana. Hold on about one time. And name the short. Jenny and Giovanni and Javier. Inia, Patterson, Inia. This is your first class? I don't know that name.
Yes, sir.
Yes, you have to go pay. There's a fee for you to join late. And we don't count in Jamaican dollars, we count in pounds. All right. So even if you have not read, I keep saying even if you have watched the video before, don't say you watch the video already and good. Go through the video again, access the classes on more than one occasion so that you become versatile on the information, right? This is a good time to be studying, to be going in school, going to school, especially when it is that you're having Zoom classes of this nature and the classes are being recorded and you can access a class at any point in time and hear the sort of live feed, in what is happening. So I trust that you couldn't find a video. It's there, man. I'm gonna ask somebody to repost the YouTube link again so that those persons who are joining us for the first time can have access to it. But yeah, man, once you go into the YouTube channel, you see quite a number of videos. I have named your videos. Yours in particular, of course, is called Cape Integrated Math. So don't look at the calculus one and the pre-calculus and the business calculus and all those fancy names. There are one or two of those videos that I'm going to ask you to access, because when I move into calculus, there are some areas in it that I want you to not listen, but watch and to help sharpen your skills. So I'm pretty excited about this because I now have a repertoire of my classes, so I can point students to those stuff to look at. So I'm going to ask you to just do this stuff. Remember now, as you are studying, don't wait until the last moment for you to start doing anything, because trust me, the time wasted today will never be regained tomorrow. So those are my few words to encourage you as we start this sojourn, this 3-hour-long sojourn. Don't know about you, but if I were to be very frank and honest with you, I honestly look forward to my class with you. I'm liking the group, and I'm liking the fact that you guys are saying that you're understanding. No, being a teacher for so many years, it's one thing when students are saying that they're understanding when the question is asked, and because say Mr. Shan don't want to answer the question because he don't want the rest of them to know that he's not understanding, so I'm just going to go with it. I really want perfect honesty. If you're not seeing it, just tell me, sir, here the plan. I'm answer this or I'm not understanding. Just get real. This is a family, and we're going to get real in this family. In this family, sir going to get upset with you 1 or 2 times, but it doesn't mean that sir don't care and love you the same way. It's just that sir wants the best of you. So when sir get upset and miserable on you and talk very sharp, it doesn't mean that there's any love lost. What it means is that sir knows that there is much more potential inside of you, and that I want to bring out that sort of potential. So it's a family. I try for you to feel very comfortable in this family, and as a result of that, I'm going to ask that you just feel comfortable and do what you need to do, and we're good to go. All right, so we went through those. We went through those. We went through the logarithms, right? And we did a conversion from the logarithmic form to the index form, right?
Yes, sir.
Yes, sir.
Nice.
Yes, sir.
And we did these questions, right?
Yes, sir.
Nice, nice. And when you're not seeing a base, you assume what number?
10.
10.
Very good. And LOG is the same thing as LG, right?
Yes, sir.
Yes, sir.
Yes, sir.
Life's good, man. Right? So you can't. So these are some little tips that you can't go wrong with. All right? Some very serious little tips that I want you to always remember. And remember your conversion from the logarithmic form to the index form, vice versa. I think this is where we're supposed to start today, right?
Yes, sir.
All right, good. So now, very important, as I said before, I'm going to give you a little tips of, maybe just one tip that I used to do when I was going to school and doing, we call it now. What did I do? A-level mathematics. That was something else. I mean, it's you guys get life easy when they talk about Cape Math. Those days we had to study over 2 years before we write the exam. So it's like on at Cape 1, and at the end of year 1 you do Cape 1, and at the end of year 2 you do Cape 2. You'll go lower 6 and then upper 6, and then you get one big exam to study things over 2 years. It was rough. When I say rough, it was very rough. But I'm going to tell you how it is that I stayed afloat. And I want you guys to practice it, especially for the integrated math. I am looking forward. I have 20 plus of you in here, and I'm looking forward for about 20 grade 1s. Nothing less than 20 grade 1s I'm looking forward to. So here's the trick to it. You're going to get either a pack of folder paper, or you're going to get a second notebook. You're going to get a second notebook. So for example, sir says to you, express 5 log to the base 5 of 625 equals 4 from the logarithmic form to the index form. You're going to go through, and you do it in class already now, but this is you doing your own preparations now to make sure that you're understanding. You're going to write back all of them 5 questions here, and you're going to do the questions out of your head on your own, and then you're going to go back and look to see if you get all the answers correctly. See the one that you get wrong? You put 1 line through it. Don't mark it out and don't use a white out and don't tear the paper. No, just put 1 line through it, so that when you're revising, you can see the mistake that you once made, so you don't make that mistake again. And the one that you get wrong, you're going to look at the solution. When you think you understand what does that mean, you're going to write that question afresh in your notebook, your home notebook, and you're going to work the question one more time. And you're going to do this as many times until you get the question, and the question is inside of you. The truth of the matter is, you can't unlearn good behavior. So when you learn something, it may it pushes to the back of your headspace, and then the new information is at the forefront. But if you go and you rake it up, you're going to have the information. Say, yeah, mom, we did this already. This is easy, 1, 2, 3. But if you wait until moments before a test or an exam, that's where you're going to have a challenge. So I'm depending on you, my students, depending on you, that you are going to do what is required of you. And as I said before, let us have an open relationship. You know, when I come to class, you speak to me openly about what it is that you're having. And here I say, speak to me, I want you guys to speak to me. Last Friday, the class ended well, but at the start of the class, I was feeling a little drained and wondered, what is it that I did to myself? Maybe I should have asked somebody else to do it, and then, you know. But by the end of the class, I had a change of mind and a change of heart. And I pray that I will never, ever have that feeling again whilst we are teaching and learning this course. So I really want you to speak to me. All right. So we're going to be looking now at some evaluation. And for those of you who are just joining, I think there are 2 such students who are now joining. Sir does his online class a little differently than how your other lecturers may have, you know, or are doing it. I do write on the screen, but for now, I choose to, because I have this thing already prepared for you, I will go through some stuff. There are areas that, especially when I'm moving on to graphs, that I'll have to, you know, demonstrate by writing on my screen. And don't worry about it. I have the requisite devices at home to let the online class be as real as it possibly can to the face-to-face. It cannot substitute the face-to-face. There's nothing like the face-to-face class, but I can get as close to real for the online class, and that's what I'm going to be doing for you, and it's a promise. And as such, if you don't feel like you're catching it, that's why you need to say something to me. Now, as you would have seen, let me see if you see it, because I really, we serve for tonight, you know, I better make sure you have a cup of tea, you know, because we're going to do some big school maths tonight. Okay. Just like when we are doing, did we do any? No, we don't really start any calculation. We're just doing conversions. All right. So, okay, that's it. So there are times when you're going to be getting questions to evaluate, and you have to, oh, Natalie, thank you. Text me at that for me to add you to the group. Thank you very much. You know, this is a different level of responsibility that that I like. You know, thanks very much, my able admin person. Without even me asking, big up yourself. One extra 1% for you. All right. So there are times you're going to be getting questions, and you have to be moving from the logarithmic form to the index form and vice versa. When I finish off logarithms, I'm going to give you a past paper question that I was searching over the weekend. I was doing some solutions on the areas that we've already covered, and 1 or 2 of the areas that we are going to be doing next. And you get the question, and you have to move from one form to the next form. So you can't just say they work logarithms and work logarithms alone. No, man. Sometimes you have to move from the logarithms to the index, and then move back from the index to the logarithms in order to get your answer. So you have to be very versed on both of them. So which is why the very first law we looked at was a conversion from the logarithmic form to the index form and vice versa. So in a case like this, where it says evaluate log to the base 4 of 64. Now let me tell you a story. All your calculators, I'm assuming, are cheap calculators, and your calculators can only work log to the base 10. Most of the calculators can only work log to the base 10. Now, if you have a high grade marijuana calculator, you can work log to a different base, any base. All right. But most of the calculators on the market now are only in log to the base 10. Now, if you are given a question like this, log to the base 4 of 64, if you put log 64, it's not going to be the correct answer. Why, sir? because your calculators are calibrated for the most part. I know some of you have some very high-tech ones, even higher than mine, but for the most part, your calculators are calibrated to log to the base 10, but this one says log to the base 4. Then, sir, it makes a difference? Absolutely. So log to the base 2 of 64 is a different value from log to the base 4 of 64. And it's different from log to the base 3 of 64. All right? So you have to be very careful of the base, and which is why last Friday, I took some time out in order for you to get the jargon of mathematics. Log to the base 4 of 64, not log 4 64. You have to get into the mood and the swing of reading the math, so it is that it makes a lot of sense to you and the person that you are communicating to, right? So log to the base 4 of 64, we need to evaluate it. So of course, it's an expression. How am I going to evaluate an expression? Sir, I can't evaluate an expression. There's no way at all that I can evaluate an expression, sir. Fair enough. So that's why I'm going to let x be the unknown. I'm letting x be the unknown. And then I'm going to create an equation, because they want me to evaluate. We can't only evaluate equations. That means the left-hand side is going to be equal to the right-hand side. I can only simplify an expression. So anybody who move from here so without having converting this here so into an equation, you're going to lose a mark. Because as math students, you must know that you can't evaluate an expression. You can only do so with an equation. Okay, so I'm going to let x be the unknown. And then I'm going to let log to the base 4 of 64 be equal to this x. Now I'm going to convert from the logarithmic form to the index form. We know this. The base is the base is the base. It's all about the base, about the base, about the base. The base is a base. The logarithmic form, the index form, it does not matter which form, the base is the base. All right? So it is going to be this, crisscross, log to 4 to the x equals 64. You're crisscrossing. 4 to the x equals 64. See here? 4 to the x equals 64. Now, one of the things that we try to do is to write the left-hand side as an index in a similar base to that of the right-hand side. And there's a trick about this, I don't ready to tell you yet, because I'm really hoping that you guys can look at it and say, sir, I discovered something. If you don't discover it by the time I'm finished with this topic, which incidentally is pretty soon, then I will tell you. I will tell you. So I'm trying to write my left-hand side and my right-hand side in the same base. No, I recognize that 4 is the same thing as 2 squares. So I'm converting this 4 into 2 squares. And then, of course, I have to put it in parentheses, because remember, this 4 up here is being raised to the x power. So all of this inside here is 4, but I'm only simplifying it to something smaller or in a workable fashion. So I still have to put my power outside here. And then this 64 now is the same thing now as saying, I don't know, sir. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Oh, sir, it's 2 to the 6. And that's why I have this 2 being raised to the 6th power in order for me to get 64. All right? Now recall, a base raised to an index, which is raised to another index, says that I multiply both indices. So a to the m raised to the nth power is going to be equal to a to the mn. Always remember that. A to the m raised to the nth power is going to be equal to a to the mn. So I'm multiplying my indices. So this 2 is going to be multiplied by this x to give me 2x. So now I have 2 to the 2x. You see that magically I am removing my parentheses because I have done this sort of conversion from my laws of exponents. My laws of exponents tell me that I can do this. All right? And then similarly, 1 times 6 is 6. I now have 2 to the 6. The bases are the same. Now, since the bases are the same, we can equate our powers. Since the bases are the same, we can equate our powers. So we're going to have 2x is equal to 6. Then, sir, does we can drop off the base, so? Same so. Same so. And when that happens, I'm going to, of course, divide both sides by 2, and I'm going to be left with x equals 3. So now your statement is going to be log to the base 4 of 64 is going to be equals to 3. Sir, I follow exactly what it is that you're saying, but why you go through the long way, sir? Because, could I write 64 as 4 to the 3rd power? Is 64 the same thing as 4 to the third power? Tell me.
Yes, sir.
Okay. All right. So alternatively, I can go do the same thing. All of this is the same as the one up top. But right here now, I recognize that 64 is the same thing as 4 to the third. See here, 4 times 4 times 4 is 4 to the third, which is equal to 64. And of course, the question is finished even quicker than the one before, because right here, I don't have to go and apply the law a to the m raised to the nth power. Then, sir, why take us through that? Because sometimes you may be slower than somebody else. So somebody may easily recognize that 64 is the same thing as 4 cubed. You know, see that? You see 2 to the 6. You can work your 2 to the 6. Take your time and work your 2 to the 6. You're going to end up with the same answer, x equals 3. Don't watch no face. You're going to get the same answer. You get the same number of marks. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, could you go over it again for me, please?
No
After
problem.
the-
No problem. No problem. We'll do. We'll do. All right. I am watching this thing here because I'm seeing some students popping in. Okay, he just came. Mr. Tarek, you are late for class. All right, let's go. So, Midfield, what do you want me to do? This one you want me to explain again, hon? Can I?
Yes, sir.
All right, cool, no problem.
No, sir, do the longer one. The longer one.
The longer one. All right, no problem. No problem. No problem. Your wish is my command. All right. So what I'm saying to you is that you're given a question. Evaluate 64. Log to the base 4 of 64. Remember, if your calculators can evaluate something like that, fling it in at the calculator, see what your answer look like, and then work towards that answer. But remember, you can't just put on the answer, you have to show them the working out. So if your calculators can evaluate it, you're not going to don't do it. Do it. Do it. And then you know what answer is supposed to be working towards. So as Sir said, that's an expression. Log to the base 4 of 64 is an expression. So what I want you to do is to let x be your unknown. Then, sir, you have to use x. If you want to use A, B, C, one Stickman, one BMW, anything you want to use to represent the unknown, you go ahead and use it. All right? I chose to use x as my unknown. So I'm letting x to be the unknown. So therefore, log to the base 4 of 64 is going to be equal to x. Now I'm going to be converting from the logarithmic form to the index form. I'm converting from the logarithmic form to the index form. From the logarithmic form to the index form. The base is always the base is all about the base, about the base, about the base. The logarithmic form, the index form, the base is the same. That never changes. Now watch me. From the logarithmic form to the index form, the base to the power equals this. The base to the power equals this. The base you criss, then you cross. The base you criss, then you cross. 4 raised to the x equals 64. You're crisscrossing, and that's what it looks like. So the aim, if you're using logarithms, sorry, if you're using indices to solve this question, it's fine. You could also use logarithms to solve this question, but I'm not there with you yet. I'm not there with you yet. All right? So if you're using indices to solve this question, what it is that we're going to be doing is looking to see how I can write my left-hand side in a format similar to that of the right-hand side. What do you mean, sir? I can write 4 as 2, the base 2, raised to a power, and that power is equal to 6. Oh, so that means, sir, you're saying that you're going to try and work 64, write 64 into a base 2. Very good. What is that, sir? Let us check. 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32, and times another 2 you can get 64. Okay, sir. So how I see you get 2 to the 6? 1, 2, 3, 4, 5, 6. So I have 6 of them. So that's why I have 2 to the 6. But sir, did you teach you that? Absolutely. This is 2 to the first power. When you're not seeing a number as a power, you assume what number?
1.
10.
No, not the logarithm, you know, not 10, 1. Power, not the base I'm talking about in the logs, you know. When you're not seeing log written to a base, you assume base 10. But when you see a number that does not have a power, you can assume the first power. Now the law says when you are multiplying and the bases are the same, you add the powers. No, all of them two look like them 2 to me, the same 2 to me. So this is going to be 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5, plus the last one is 6. And that's why I get my 2 to the 6. All right. So that's what I'm going to write, my 2 to the 6. So my 2 is the same thing as that to the 6th power. And I put this 1 here. You notice my 1 here, I put it in blue. Why, sir? I put it in blue because I want to emphasize the point that whenever you see a number, a whole number, magically that whole number is being raised to the first power. Then, sir, what if it erases the 2? Then it's raised to 2. Oh, so it's only if you're not seeing a number, sir, you can assume that it's raised to the first power. Very good. All right. So that's why I put this one in blue to show you that this is going to be 2 to the first power. Now the law says a to the m raised to the nth power is going to be equal to a to the mn. What the law says is when you have a base raised to a power, which in turn is raised to another power, you're going to be adding, you're going to be multiplying both powers. So a to the m raised to the nth power is going to be equal to a to the mn. It's going to be equal to a to the mn. So now I'm going to have 2 times x. Sir, which 2? There are so many 2's there. We're talking about the powers one them now. So this power 2 times this power x is going to give me 2x. We're not adding, we are multiplying. And 1 times 6 is going to give me 6. Now, since the bases are the same, we can equate the powers. Now, there's going to come a time when we are working the question, and if we have an equality, the bases are different, but the powers are the same, we are going to equate the bases. All right? But I'll come back to that at some point in time. So since the bases are the same, we can equate the powers, right? We can equate the powers. So 2x is going to be equal to 6. So my 2x is equal to 6. And of course, you know this. I'm now trying to isolate my x. So I recognize that the 2 is being multiplied by x. So in order to get rid of the 2, I'm going to do the opposite, the inverse of multiplication. And the inverse of multiplication is?
Division.
Very good. Very excellent. It's going to be division. So it means that I'm dividing both sides by 2. So I'm going to have x is equal to 6 over 2. And then that is, of course, is going to be equal to 3. So one of the things that I want you to get in the habit of doing, I've always done it. I want you to be able to write your mathematical statement at the end of it. Don't allow the examiners to be searching for the answer. I'm going to tell you why. When the examiner is searching for the answer, every mistake you make, them they find it because they're searching. Now, if you can write your mathematical statement at the end and you lay it out, you see, if you make one little mistake up at top, them now see it because them glance at the answer and say, blow, wow, the student write out the answer nice. Log to the base 4 of 64 is equal to 3. That's my answer. And you get the mark. But if you left it off and the man go search for the answer, you're giving them opportunities to find some little errors that you are possibly making. And you don't want that to happen. All right. So always get into the habit of doing your writing your mathematical statement at the end. All right, Shan, any clearer?
Yes, sir. Thank you.
Let's go. All right, now, based on what it is that we just did, based on what it is that we just did, let me reduce this because you know that you know how sir doing things. Not because we come class and we have these nicely typed up lessons and you know, sir is so nice to you that him go and him we call it now, send you a PDF of the lessons after class. Matter of fact, how many of you in this class appreciate what it is that I'm doing in terms of these PDF documents? Let me see if I can catch it now. Anybody appreciative of it?
Yes,
All right,
sir.
I see
Yes,
Tantan
sir.
and I see Giovanni. All right, good. All right, good. I see the hands going up. Great. Now, what do you think I mean by appreciative? I'm going to ask Amelia. Amelia, unmute for me and tell me what do you think I mean by appreciative of it?
Sir, meaning that we read it over?
Me now go no for save up to say, wow, sir, give me soft copy. Me want uno to read it through and read it and read it and read it and read it. Now, one of the things that I'm going to say to you, as I've said to my other students, don't print it yet. Some of you may have access to printing facilities. Don't print it yet. I'm going to tell you why. You know how me love going to my document and change some stuff to give you further explanation, eh? So when I tell you, say I'm finished with unit unit 1, or I'm finished with unit 1, then you can go ahead and print your unit 1 because we start in unit 2. So in module 1, we have several units, right? In module 1, I think we have 8 units. All right. So I chose to start at logarithms and exponents. It's when I said to you that we are finished with logarithms and exponents, that final copy is what it is that you're going to be printing, marking up, and digesting the information on it. Trust me, if I were a student, I would have loved this to happen. So don't just get it and sit down and say, yes, sir, they send it. I want you guys to use it. And when you're using it, use it in tandem with the recordings. All right. So what I want you to do for me, look over in kitchen with number 4 and number 5. There is not one student in the class that will be able to get question 4 and question 5 right. John Mark, you can't get it right. Giovanni, Shanti, Natalia, Natalie, Kimoli, none of them can do 4 and 5. I bet you they can't do it. Do me a favor. Prove sir wrong tonight for me. I'm giving you 5 questions and I want you to evaluate the logarithms. I'm leaving this example here so it is that you can look at it. And I'm giving you, because I know you're not going to be able to work with 4 and 5. Let me give you about 6 minutes. 5 minutes to do them 3 here. No. Yeah, I'm here about 6 minutes. So I'm going to mute and I'm going to ask you to just go ahead and start working, please. Prove me wrong, you know. Giovanni and Javi and Shanti and Janae and Kimoli and all of you know. Prove me wrong. Start working. How we stay? John Mark, unmute for me, please.
Yes, sir.
What question I got to? Finish all of them?
No, sir. Two alone.
Two alone?
No,
Alright.
number two. Number one.
Number one and number two we did?
That's number two alone, sir.
What is this number two alone we did?
Uh,
Okay, so what is the answer for number two?
3.
Class, is he correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Very good. I'm proud of you. Very good. All right. So John Mark, you need to work a little harder and a little faster. Congrats, though.
Yes, sir.
Man, no problem. Kimoli, your turn to unmute.
Sir.
Numero uno. Have you done number one?
Yes, sir.
What you got for the answer?
Sir, I got one.
You got one?
Yes, sir.
Is Kimoli correct?
Sir, which number?
Sir, which
Are you
number?
talking about?
Number one.
That's what I got. So
No, sir. Sir, I got -1/3.
You got negative 1/3?
Yes, sir.
That's what I got to say.
Okay. So Sterling and Hines got negative 1/3. All right. Kisano, what you got?
Sir, half of a tree.
You got half over 3.
Yes, sir.
Okay. So why are you laughing?
Kind of understand.
No, not at all. Let me tell you that. Let me tell you that. You get half over 3. I'm happy that you gave an attempt to the question, which is very good. Giovanni, what you got for number one?
Sir, same thing, -1/3.
Negative 1/3. Okay. Two more peeps. Powers, you came to class late. Come, talk to teacher. Tariq,
Yes, sir.
what you got for the answer for number one?
Negative 1/3.
Negative 1/3. All right. Patrine, what say you?
Sir, I don't know.
I don't know how to write that one. How you write I don't know, Patrine?
Sir, I didn't do it.
Okay, all
So
right.
I tried, but I didn't finish.
Okay, no problem. So don't unmute it because we're gonna be continuing that conversation. All right. What was the first line?
Log 8 0.5 equals x.
Stop it. Is she correct?
Yes, sir.
Yes.
Is that the first line?
Yes, sir.
Is that the
So you
first
have to,
line?
so you have to use our equation first to evaluate it.
Okay. Is that the first line?
sir, my first line
Mm-hmm.
is 2 raised to the power of 3, and they have x outside of the bracket equals 0.5.
Okay. Patterson, is that the first line?
Sir, I didn't attempt it.
Tough. I will keep it a class tonight. No, man.
Sir, my first line is 8x equals 0.8 to the x power.
So my first line is same as Gardens.
Sir,
Yes, please.
sir, my first line is just the question.
What question? What is the question? Log to the base 8 of 0.5. That's your first line?
Yes, sir.
Okay.
Equals x.
Equal x.
Equals this. Okay.
Yeah.
So like the unknown.
Who said that?
Natalia.
Natalia, thanks. Thanks here, Natalia. Thanks. Because everybody's going to talk about, sir, 8 to the x is equal to 0.5. Where x come from? I never give no question with no x. Aha. So you have to let x be the unknown. You can't just introduce something to my question without me asking you, without you defining what it is that you're introducing. So Patrice, come again. Me and you talk again now. All right. So you understand why my first line is let x be the unknown?
Yes, sir.
Okay, so tell me your second line now.
Log 8 base of 0.5 equals x. Log base 8 of 0.5 equals x.
So log to the base 8 of 0.5 is equal to x. Very good. So you understand now why that is really and truly the second line and not the first line?
Yes, sir.
Yeah, because you have to make x in it. And I don't want you get shy, you know. You see, because you say you never finish something, that's why I'm working it with you, right? So you will help me teach this question tonight because you're catching it. So you have to let your first line be let x be the unknown, because you can't just go and say log to the base 8 of 0.5 to be equal to x. Every time we get x from, all right? So now that you have that line, Patrice, what is your next line?
8x equals 0.5.
No.
Oh, no converting.
You said 8x equals 0.5. I can't write, Patrice. 8x equals 0.5. Is she correct? 8x equals 0.5?
8
No,
raised to
sir.
the
It's 8
power
to
of
the x power.
8 to the power.
All right, Patrice, you hear what them say?
Yes, sir.
What them say?
8 to the power of x equals 0.5.
So important it is. Very, very important. I'm going to tell you what this is. As a science student, this is you, the anesthesiologist says 0.5 cc. I said, sure. You can't catch 0.5, I'm going to catch 0.7. You kill them, you know. You kill the patient. Good time too. Good time. So you have to be very precise with what it is that you're doing. All right? Okay. Now, what is your next step, Patrice? So 8 raised to the x power equals 0. Oh, that's where you stop.
Yeah.
All right. Who you know in the class?
Sir Natalia.
Nathania, unmute, please.
Yes, sir.
So your friend, Miss G, just tagged you. So you hear when she said she finished? She said she stopped at the point where 8 raised to the x power is equal to 0.5, and she said she's never going further. No, she's a friend. Tell her what is the next line. Nathania?
Yes, sir.
You're gonna let down your friend? Tell me what to do. You don't have to give me you don't have to tell me what it is that you did on the paper. Just tell me what you need to do from that point. 8 raised to the x power is equal to 0.5. What is the step that you need to do? You don't have to get the step correct, but just tell me, verbalize to me what step you're supposed to be taking next.
To find a lower number.
Okay, continue. A lower number what? You're on the right track.
Can be raised to a power to give 8.
And what lower number is thinking of, Nathania?
2.
Listen to me. Don't answer me tentatively. Answer me boldly. 2 what?
2 raised to the third power.
What's your name? Say it loud, ma'am.
2 raised to the third power.
Congratulations. Very, very, very good. So what do you know about? So 2 raised to the third power all raised to the x power is going to be equals to 0.5. Now remember, sir said that what you need to do is to make sure that the left-hand side can be written as the right-hand side. Can you convert 0.5 into a base and power, and that base is going to be 2? You're on the right track so far, and so continue.
I don't know what else to do, sir.
Who you know in the class? Tag somebody else. Tag somebody else. Quickly, quickly, quickly.
Aniki.
Aniki, on you, please. Nikki. Nikki, nobody here. When I call up a national answer, me I have to turn to the waiting room. Nathaniel, call upon somebody else here, please.
Tatiana.
Tatiana, which of them?
Green.
Green. Hi. Your turn, Miss G.
Yes, sir.
So you heard what was said earlier, right?
Yes, sir.
So very quietly she said she's going to convert the 8 into 2 to the third power. Is she correct? Tatiana, come on, guys, talk to me now.
Repeat.
Okay, so Tatiana, you keep answering and then muting and then taking a while to unmute. Can you just unmute for me, please, and let us have a conversation without you muting every time? Please. I'm saying what was said is that the 8 can be written as 2 to the third power. And I'm asking you, what can be done to the right-hand side of the equation? The 0.5 in particular.
Sir, I don't know what to how can write it towards the base.
Kimberly, can you unmute for me, please?
Sir?
Oh, thank you. How can I write 0.5 into a base and power, and that base is 2?
Sir?
Not sure?
No, sir.
Okay. I'm coming, Giovanni. I'm telling you.
Sir, is it 2 negative 1?
2 raised to the negative 1. Is Tennille correct?
Yes, sir.
Yes, sir.
Yes. 2 raised to the negative first power. All right, let me just pause and say something here to you. You know why I'm doing this exercise? I'm doing this exercise because when I asked a question earlier at the start of the class, is everybody following? Just one lone somebody, one dege somebody whose class is the first time turning up answered me. I know that there are other students in the class that are not. So 100% with what we're going with and I'm not talking. And that's why I'm doing the exercise I'm doing. Not because I have a lot of time to waste, but to get you guys to participate and to get you guys to answer. Now, I know Aniki don't unmute, you know. So the way I stopped the class is to say to you, when I ask a question and you decide that you're not answering because you don't know or for whatever reason, I am going to put you into the waiting room, because when I ask you the question and you don't answer me, it means that you are not in my class. So I'm going to drop you into the waiting room. Real talk. So if I say to you, Javier, can you unmute and answer this question? I'm going to call it 2 and 3 times and put you into the waiting room. Answer me, talk to me, boy, sir. I'm still following, or sir, you know, I think the answer is this, or sir, I don't know, but I want to hear from you. If I don't hear from you, I'm going to put you into the waiting room. And when you get to the waiting room and you're alone there, I will come back and check on you to see if you're back in class. And I'm serious about it. So, Miss Aniki, you get with this time.
Oh, sir, I'm so sorry. I had to go out in the kitchen to do
They
something.
not talk to you
Oh,
because look how long me are calling
sir,
and answer me.
let me
Miss
leave
me,
your stuff and go out in the kitchen. I'm so
I
sorry, sir. I'm so sorry.
I pray that the food we go for don't taste as nice.
I mean, they're running on me and they're running
All right.
upon me. I'm so sorry, sir. I'm so
Okay, I forgive you. I forgive you. I really forgive you. But in general, though, guys, in general, whenever I call upon you, I really want you to answer, right? I am doing this not because I'm intending to embarrass anybody. This is a class. It's a family. I'm doing this because I want you guys to catch it. All right. So, Nikki, you're going to go eat some food. So I forgive Nikki. All right, let's go. So, yes, it's going to be 2 to the negative 1. It's going to be 2 to the negative first power. So, I don't even have that here. So the answer is indeed negative 1/3. Let me see if I can write something for you, because I recognize that a few of you not understanding. Now, there are a few of you in the class that I pick up that will, oh, that's what is that are understanding. When I call upon you, you give me the answer, and you always willing to volunteer a solution. Very nice. Very nice. Let me just write something here for you. Log to the base 8 of 0.5. So log to the base 8 of 0.5. Log to the base 8 of 0.5. Now, remember, I'm going to let x be the unknown. I'm going to let x be the unknown. So therefore, I'm going to have log to the base 8 of 0.5 is equal to x. So now, let's Forgive me here. I don't know what is wrong with this thing, but so now 8 raised to the x power is equal to 0.5. And 0.5 is the same thing as a half. When it knocks in a power, assume to the first power. So you're going to have 2 to the third raised to the x is going to be equals to, sir, if I take this 2 to the numerator, it becomes 2 to the negative 1. Recall, 1 over a to the m is equal to a to the negative m. So it becomes 2 raised to the negative first power. Now, oh dear, oh my lord. All right, all right, I have to screen it up because my screen can't move because it's frozen in that thing that I was writing in verbal language, so forgive me. So what I'm going to have is going to be 2 to the 3x. So where you get the 3x from again, sir? Don't worry about it. A to the m raised to the nth power is a to the mn, and it means that I'm going to be multiplying my powers. So 3 times x is 3x. And this is going to be equal to 2 to the first power. Now we have a statement to say, since the bases are the same, we can equate our powers. So I'm going to have 3x is now equals to negative 1. Divide both sides by 3. X is going to be equals to negative 1/3. Look at it, talk to me, let me know how you feel about that. For those of you who weren't seeing it before, are you seeing it now?
Yes, sir.
Nice.
I get it, sir.
Good job. Good job. All right.
Sir, for number 3, I don't really know how to simplify the 9.5. So I only did half of the equation.
Okay, and that's fine. And that's fine. But before I do it though, let me ask, is there...
I didn't see how you get the negative 1/3.
You didn't say I get it? Oh no, then suppose I tell you say I erased it already. You remember I said to you that the first part was written in something else? So when that straight screen, that first part went. So forgive me with the first part. But the second part you will have.
Sir, or it become negative over 1/3.
How it becomes negative 1/3? That's what you're asking?
Yes, sir, because first it have 2 to the negative 1 power.
Remember, you know, a half, 0.5 is the same thing as 1/2. Talk to me.
Yes, sir.
1/2. And then what you're doing now is that you may have 1/2 and it's 2 to the first power. 2 to the first power. So when you take that 2 to the first power into the numerator, it becomes 2 to the minus 1 power. See the law here? The law says a to the m raised to the nth power is equal to a to the mn. Sorry, I give you a different law. The law that says 1 over a to the m, 1 over a to the m is going to be equal to a to the negative m. because this m is in the denominator. Positive m is in the denominator. So it becomes, when I move it now to the numerator, when I move it to the numerator, it becomes negative m. You remember that law that I gave you? Talk to me now. You say you're not seeing it, so I'm trying to explain something to you. Green, was that you asking me the question earlier?
Yes, sir.
Talk to me now.
I'm
What you gonna say?
listening.
Me ask the question and not answer me.
Background was very nice. I couldn't answer at the moment.
All right. This is a law. A to the positive m. When I take this positive m into the numerator, it becomes a to the negative m. You notice the sign changes? It is positive m in the denominator. When it goes into the numerator, it becomes negative m. If this were negative m in the denominator, when I take it to the numerator, it becomes positive m. So it said
Yes, sir.
when you have a base raised to a negative index, you reciprocate. All right? So that's exactly what is happening. All right, so let me go right on. She said yes. I'm just looking at this and there's a whole lot of work we've gone through already in the first 1 week of class. Wow. Okay. So somebody was saying to me earlier, sorry, I didn't even see who was speaking. Somebody was saying to me, sir, I don't see number 3, how you get the 9 raised to the half power. My question to you, has anyone gotten the answer for number 3?
Yes, sir.
Yes, sir.
What's the answer?
Uh-huh.
Uh-huh.
Sir, I got 1.
You got 1? And I
Yes, sir.
skip also that. Tony,
Yes, sir.
I like your boldness. If I want to get, I want to get, and then we will work it out and see if you're right. Very nice. What about the others? Anybody else get anything other than the half or 1? All right. So for those of you who had an issue, so I'm going to let x be the unknown. So I'm going to say log to the base 8 of 0.5 is equal to the unknown x. Now I'm converting from the logarithmic form to the index form. So I'm now going to have 8 to the x equals 0.5. 8 raised to the x power is equal to 0.5.
So this is not number 3. Are you
I know.
redoing number 1?
I'm reading number 1, yeah. The Spirit of the Lord instructed me to do it, so I'm doing it over. There's somebody in the class who is sitting down, not having a clue where they're going with, and then they say, me, now ask her no question. So, I'm doing this for that person. I'm doing this for this person. So this 0.5 is the same thing as a half. I notice I put my 1 here in blue because we don't normally write a half, 1/2 with 1/2 raised to the -1 power. But I'm putting that power there so that you can see that there's an imaginary 1 that is up top. That there is an imaginary 1 that is up top. And then when I take it into the numerator, it becomes 2 to the -1. 2 to the -1. And then the law that says a to the m raised to the nth power is equal to a to the mn. I'm going to be multiplying this 3 by this x to give me 3x. Now, since the bases are the same, I can equate my powers. Since the bases are the same, I'm going to equate my powers. So what do you mean by that? It means that I'm going to drop off the base them, and the 2 power them, I'm going to equate them. Oh, so you said you're going to make 3x to be equal to -1, sir? Yeah, right here, so 3x to be equal to -1. And then I'm trying to isolate my x. So what do you mean by isolate the x? I'm solving for x. I want x alone to be on one side and everything else on the other side. So I'm dividing both sides by 3. So why divide by 3? Because the 3 is being multiplied by the x. And the opposite of multiplication is division. So I'm going to be doing I'm going to undo it. So it means that I'm doing the opposite or the reverse of it. So when I divide both sides by 3, I'm going to get x to be equal to -1/3. The number 2 question. LG is the same thing as logarithm. LG is the same thing as LOG. Same thing. When you're not seeing a base, you can assume base 10. See, I put in a base 10 there. So why I put it in? Because after letting my x be the unknown, I'm now going to convert from the logarithmic form to the index form. So I'm going to say 10 raised to the x power equals 1,000. See it right here, so. What you do after that, sir? You're going to try for the right-hand side to be written in a base 10 raised to a power. Would that be 10 cubes, sir? Very good. See here, 10 cubes. Why did you get 10 cubes, sir? Because it is 10 times 10 times another 10. Now, since the bases are the same, again, we can equate our powers. The base 10 here is the base 10 here. So in order for this value to be equal to this value, means that the bases must be equal. The powers must be equal, I'm sorry. Since the bases are already equal, therefore the powers must be equal. So I'm equating my powers. So I'm going to have x equals 3. And that's how I got my x equals 3 for this question. Are there any questions?
No, sir.
No, sir.
No, sir.
Very good. Very good. And then now, the question was asked. You notice I have a little love letter right here, so a little love note. We will see this a little later. So telling you, your little friend, your very good friend, see you later. It means say, you're truly looking forward to seeing this person a little later. You're really looking forward to see this person a little later. So we're going to be looking forward to seeing this person a little later. Watch me. Again, we're going to let x be the unknown. So you're going to have log to the base 9 of 9.5. 9 to the half power is going to be equals to x. You don't matter how the something look. Look cute, look handsome, look pretty, look wishy-washy, it doesn't matter. Once you set up your equation, go right ahead and convert from the logarithmic form to the index form. It absolutely does not matter how it looks. Just make sure that you have your equation and just make sure that you convert from the logarithmic form to the index form. It will work out. So converting from the logarithmic form to the index form, I'm going to say 9 raised to the x power is equal to 9 raised to the half power. The base is the base. It's all about the base, about the base, about the base. So it's 9 cross 9 raised to the x power is going to be equal to 9 raised to the half power. Now you would agree with me that the bases are the same. So in order for me to obtain equality for this question, it means that the left-hand side must be equal to the right-hand side. But the bases are the same. So by extension, it means that the powers must also be the same in order for things to happen between us. We are compatible. We don't want to find somebody that is not compatible to spend, oh, come on, no man, sure. To spend our life with. Yes, stylus just fail. I hope it don't break. All right. So what we're going to be doing, since the bases are the same, we're equating our powers. So x is going to be equal to a half. X is going to be equal to a half. Now this here is important because I will take you to see this one a little later on. Soon come. Now, are we feeling a little, you notice my countenance change because I'm trying to get you at a point where it is that you can understand. So everybody see question 1, 2, 3?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes,
sir.
Nice, nice, nice. Feeling a little bit more comfortable. I know some of you have gotten it, but you know, you can see exactly what it is that I did, right?
Yes,
Yes,
sir.
sir.
Yes.
Sir.
All right. Now I want to see who is going to be the bravest one in class tonight to tell me the answer for question number 4.
Sir?
Sir.
Sir, me get
Sir,
25.
we get 25. 25.
25.
I don't like when students cramp my style, you know. Because after me
Then,
just
sir,
go,
yes, if I attempt it,
no,
sir,
yeah,
yes,
but
sir, we can't do
yeah,
it, no, sir. We do it, I'll get the answer.
yeah, but
Yes,
I
sir.
mean, me give one question to bowl, you know, and then I do the question and get the question right. That's not fair.
Sir, what do you mean?
No, you just cramped my style a while ago. Me the one have the last laugh, but only laugh after me. It's not fair. It's not fair. Oh man.
Or sir, you'll probably get the next one.
Not
No.
number 5, you know, sir. Like, later down. You
Later
know, when
down.
yeah, later.
All right, no problem. That's very good though, guys. What I was using earlier was what we call reverse psychology. And I'm sure some of you say, you think so me not gonna get it, sir? And you push, and you push, and you push. Very good. For those of you who didn't get it, let's go. So log 5 raised to the log 5, log to the base 5 of 25. No, they want us to evaluate this. 5 raised to the log to the base 5 of 25. Who are keeping a John shop? It does not matter how ugly the something looks. You when I'm going through the question, you tell me if I'm doing anything different from what we would have done in questions 1, 2, and 3, right? And I'm sure you'd agree with me that questions 4 and 5 are different from 1, 2, and 3. But guess what? You can tell me if I'm doing the same steps. Let x be the unknown. Then I'm going to equate this to x. So I'm going to now evaluate log to the base 5. Look at what I'm doing. I'm evaluating the power. Let me just put that notation there. Evaluate LA I'm evaluating the power log to the base 5 of 25 first. So I'm letting that to be equals to x. And then I'm converting from the logarithmic form to the index form. So I'm going to have 5 raised to the x power equals 25. See it here? 5 to the x power equals 25. Now the rule says, as Sir said a while ago, that this 5 over here so is written as its simplest form. My aim now is to see if I can write the right-hand side into a base similar to this one. And the answer is yes, because 25 is the same thing as 5 squares. No, the bases are the same. No, the bases are the same. So, watch it. One minute here.
You know, sir, I thought I didn't have any sense because I get x equals 2. So I'm like, I'm just stupid. But no, we're just never done.
It just never finished, right? And guess what? There's no stupid in what it is that you do here. Trust me.
16 fashion job.
I'm proud of you. So you got x equals 2. But now remember, it was just the power, it was just the power that we evaluated. So now we're going to evaluate log raised to the log, 5 raised to the log to the base 5 of 25. But we know that log to the base 5 of 25 is equal to 2. So now what we need to evaluate is 5 squares. And 5 squares equals 25. So 25 is going to be the answer. So that was a trick question. Some of you never got tricked. Some of you work it halfway, but we're just a little nervous. Some of you don't start it yet, but that's fine. I guess as time goes on, you will get into the move and the groove of doing. All right. So what I want to do is, here goes the last question. 3 raised to log to the base 3 of 5. I want you to evaluate this one. I'm going to give you an opportunity to look at this and then work this one now. But before you do that, I'm going to ask, did anybody evaluate this one?
Yes, sir.
What's the answer?
5.
5.
5?
Yes, sir.
5. I don't think that's what I got. I don't think that is correct. The rest of you in class, can you check to see if these guys who got 5 was correct, please? I don't think they're right. I don't think they're right. So I'm going to give you 3 minutes to work this one using this here. Oh dear. Oh dear. Oh crap. Ah! That's why I'm not supposed to tell lies, Honestly. All right, since I have it there, let me just do it. So you're correct here. The answer is 5. You see, God don't like ugly, because I'm really saying to you that I didn't get 5 and it just switch up there to them. All right, just look at that for me, please. I'll still give it the 3 minutes to work through, to look at it, to see exactly what it is that Sir did. And then I'll just mute and just not say anything for 3 moments. Are we okay? Are we comfortable? Are there any questions regarding what it is that I've done here?
Yes, sir. I'm confused. I don't understand. I
Sir,
don't have an answer.
Hold on a comment. So John Mark, you say you're confused, you're not understanding. What are you not seeing, John Mark?
I'm not understanding, sir. Like we have log 5 over log 3. How you get that answer, sir?
Aha. Aha. Okay, now, so look at this piece here. I want to look at 3 to the x equals 5, and I want to compare to 5 to the x equals 25. Let me see if I can bring both together. Look at this piece. 5 to the x equals 25, 3 to the x equals 5. What's the difference between 5 to the x equals 25 and this one here?
Different base, sir.
Very good. So you recognize in this question, John Mark, that you can write both left-hand side and right-hand side in the same base?
Yes, sir. You're right.
Can you do the same thing right here?
Can you repeat, sir?
I'm saying to you, you can write this side, the left-hand side and the right-hand side in the same base 5. My question to you is, can you write this one question here in the same base, the left-hand side and the right-hand side in the same base?
No, sir.
No, it can't. So it says we cannot write the left-hand side and the right-hand side in the same base. Therefore, we have to use logarithms to evaluate this portion. We have to use logarithms to evaluate this portion. In order to use logarithms, I would have gone through the law hold on. Okay, what I'm doing is I just paused a while ago because I'm teaching some other courses, and I'm actually doing this very topic with them. So I was wondering where exactly I reached with you guys, which is why at the start of the class I asked, for you to tell me where it is that we were. This here is for me now to introduce something new to you. See it here? Laws of logarithms. It's for me now to introduce something new to you. Remember right here I said to you, we will see this a little later because I'm trying now to introduce logarithms to you. All right? And then I gave you something here, and this was deliberate. This one was deliberate to give you a question like this, where the left-hand side can be written in the same base as for the right-hand side. And then the next question to follow. Go ahead.
Sir, this don't relate to the last question, but I had a question about the fourth question. Could I get 5 to equal 25? That's the last one.
Oh, I get it. Oh, I get 5 to the second power equals 25?
Yes, sir.
5 times 5. 5 to the second power, is saying that I'm going to multiply 5 by itself 2 times.
Sir, no, the last one, no, we are going to evaluate.
So now we're going to evaluate 5 raised to the log 5 to base 5 of 25, but we'll just evaluate log 5 to the base, log to the base 5 of 25 to be equal to 2. So I can substitute now log to the base 5 of 25 to be equal to 2. You follow what I'm saying? No?
No.
Right. So the question was, evaluate log 5 raised to log to the base 5 of 25. The question asks us to evaluate 5 raised to log to the base 5 of 25. But in order for me to do that, I have to evaluate the power part first. So in evaluating the power, which is log to the base 5 of 25, I'm going to allow that to be equal to x. I evaluated it, and I got my x to be equal to 2. So what I'm saying to you now is, I no longer have log to the base 5 of 25. I can now substitute what up here. Talk to me now.
Okay, sir.
You see it now?
Yes, sir.
Right. So I can substitute the 2 right here, which is what we did. So this is what I'm saying. Now we are going to evaluate 5 raised to log to the base 5 of 25, which is equal to 2. What I'm saying to you is that what I'm saying to you is that log to the base 5 of 25 is going to be equal to 2. That's what we just evaluated. Now we're going to evaluate 5 raised to log to the base 5 of 25. 5 raised to log to the base 5 of 25. We know that log to the base 5 of 25 equals 2. See it right here, so? Log to the base 5 of 25 equals 2. So I'm putting it back up here, so. So what we have now is just 5 squares. Because this 2, I'm substituting to be log to the base 5 of 25. And 5 squares equals 25. Tatiana D.
Get it.
Get it?
Understand.
Nice,
Yes, sir.
nice. Let me just big up Tatiana D. I went big up because I went through the question. I actually moved on to another question and you weren't understanding. And you asked me pardon just for me to go over the stuff again, and then you saw what it is that I was doing. And that is a responsible way of learning online. Why I stop the class so often to talk to you? Because I'm teaching you how to also learn online and how to make the best in an online environment. That's what I'm doing. I'm teaching you how to learn online. And part of the greatest thing for you to do, you know, is to ask questions. So it is that we can go through. All right, it's very important. It's a very good 30D. All right. I'm seeing one, two. All right. Sorry, I was just checking my list because I'm seeing more than the number that I know is supposed to be in the class, but one person is logged on twice, so. No, but, okay, yeah, this here. All right. So what I'm saying to you here now is that as opposed to this one where I can write both left-hand side and right-hand side in the same base, in this here case, I can't write it in the same base. So I now have to use logarithms. I have to use logarithms to evaluate that portion. Now watch what is happening. I'm saying x, I'm carrying it in front of this. Log 3 equals log 5. X log 3 is equal to log 5. And I'm isolating my x's, so I'm going to divide both sides by log 5. So I'm going to have log 5 over log 3. And I'm going to get x to be equal to 1.465. X to be equal to 1.465. Now, similar to what we did up here, I am now going to be evaluating log raised to the, 3 raised to the log to the base 3 of 5, which is 1.465. So technically what I'm evaluating is 3 raised to the 1.465. And I'm going to get 5 to be my answer. I'm going to get 5. So what I'm saying to you is 3 raised to the log to the base 3 of 5 is going to be equal to 5. That's what I'm saying to you. Any questions right here, sir?
Sir,
So I still don't see where I get the 1.465.
sir,
Could you go ahead?
the 3, forget the 5. I know you get the 1.465, but combine with the 3 equal 5. I don't know where you get it still, because I put it in the calculator and I did not get the 5.
Don't worry about it. That's the least of my concerns. Giovanni, was it you who asked the question, or is John? Is you Giovanni, right?
No, sir. It's
No,
John.
sir, not me.
Is John Mark?
Yes, sir.
Okay, all right, cool. Never mind. I'm just trying to pick up the voices. All right, so not a problem. I'm not upset, John Mark, that you're not seeing what is happening. All I'm going to ask you, all of you, to do now, don't worry about it. All of you, is to take out your calculators for me. All of you, take out your calculators. And John Mark is saying, sir, I don't see how you get the 1.465. Okay, no problem. Remember, I said to you that most of your calculators are calibrated in log to the base 10. Most of your calculators are calibrated in log to the base 10. So what I want you to do for me is, I did ask that question for you to know the algorithm for you evaluating log 5. So press for me log 5 divided by log 3 and tell me what you get for your answer.
1.4649.
So I call it 1.465, right?
Yes,
So
sir.
my one say 1.020.
What? What brand calculator using, Papa?
Texas, sir.
That's something like that. But anyhow, clear the calculator for me, please.
Yes, I could.
Try it again now. Log 5 divided by log 3 and tell me what you get.
Same thing.
Take a picture of the calculator, please, John Mark, and put it in the group for me now, so I can have a look at it.
Okay, sir.
John Mark, you send it? We're waiting on you now.
So I sent it now.
Oh, you sent it? No.
Yeah.
That is the problem, Papa. That are your problem. Your algorithm, your syntax is incorrect. Do me a favor, clear the calculator again, please.
Yes, sir.
When you press log, a parenthesis is open up, don't automatically, right?
Like bracket?
Yeah. So press log, and when that parenthesis open up, close it. So close it off for me now. So press the other parenthesis on the tan to close it off for me.
Oh, yes, sir.
Then again press divided by log 3 And then now you can close the parentheses after 3 and tell me what you get for your answer now.
Oh, hold on, sir. You must put the 5 and then close it.
Yeah. When they press the 5 to close it, yeah.
Okay.
And then they press the division sign now.
Divide by 3.
And then they close it after 3 now.
I get 1.461.
1.4, right, so it's 1.465 in the round it up.
1.465.
All right, so I don't know if you were in class the last time and I was asking for persons to take their calculators out, so it is that they can know how the calculator operates. When I was introducing log 8.
Oh yes, I was here, but I didn't have a calculator at the time.
Okay, right. So that's the point I was trying to make, John Mark. That it is important that you have your calculators, that you know how to operate your calculator, because your calculator now, somebody with a Casio calculator, John Mark, didn't have to do that. Them just press log 5 divided by log 3. Somebody can support that point to be true or false?
Yes, sir, true.
Yeah, man.
No, sir, I had to do that.
I had to close the bracket.
Patrine, what calculator are you using?
Casio.
Which are the Casios? Casio who? Tell me the number. Not hearing you, honey.
FX82 ES.
What you say? FX82?
Yeah.
Okay. Okay. Somebody
I
else who.
have the calculator that he has though. Well, I have multiple, but I have one calculator that he has.
All right, Kimoli. So did you have to do the same operation like what Petrine was saying? All right. I know the FX82 is a higher version. But the point I'm making is some of the Casio calculators, and this is why I like Casio. I'm going to put it out there. My preference is really Casio. Why? Because of the user friendliness of the instrument. You know, if you forget to put the parentheses, you can get a wrong answer. But it is built in on the Casio calculators that you don't, even if you don't have to put the parentheses in there. But the point is, the overarching point I'm making is, whatever brand calculator you have, carry them to class so that you can know how to use them. So like what John Marks up and says, sir, I'm having a problem because you're getting 1.465. I am not getting that. How did you get that? And then I said to him, send me a copy of the calculator in the group. And the mere fact that I looked at how it is that you type the stuff in there, the algorithm was incorrect. So he would have gotten an incorrect answer. Once the algorithm is not correct, your answer is going to be incorrect. All right, so please, when you get your calculators, play around with it. If when I'm doing the question and not seeing it, sir, hold up. And then we can have that conversation. All right, so John Mark, you okay now then, right?
Yes, I'm okay now.
All right. Is there anybody else? I thought somebody was trying to come in when somebody was speaking just now. Is everything okay? Can I move on?
Yes, sir.
Yes, sir.
Yes, sir.
All right. It's now 7:38. I'm going to be moving into logarithms, the laws of logarithms. I'm going to be moving into that. It's not difficult. And trust me on that, it's not difficult. But I want to be able to have you very fresh. So I'm going to give you a bit of screen break now. So I give you about a 10-minute screen break. I give you a 5-minute screen break. Go and refresh yourself for me, please. If you're not even feeling tired, just walk around in your room or living room, wherever you are. just walk around and cause the blood to circulate a bit for me. In 5 minutes time, I'll come back. All right. Welcome back. Welcome back. Welcome back. Welcome back. We're going to be looking now at the laws of logarithm. The laws of logarithm. The laws of logarithm. Matter of fact, are we back?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right, good, good, good. Feeling tired or ready to go?
Sir, ready to go.
Okay, I was about to say not answer me. All right, come, listen, we should have less than an hour. And I want to get through these laws so that we can have something to work on. So that's where I'm going to stop. I'm just going to go through the laws, maybe do one or two of the examples, and then we stop right here. The laws of logarithm, and I want you to work with me. That's why I give you a little break, because I want you to work with me. So I'm going to let log to the base a of b equivalent to x, and I'm going to let log to the base a of c be equivalent to y. Sir, where are you getting those things from? You notice I said I'm going to let log to the base a of b equals x. Similarly, log to the base a of c be equivalent to y. So I am introducing those variables x and y. That's why I put the word equivalent, because I don't want to put equal. Because you're going to say, sir, where you get it from? So when I put equivalent, I can say to you that I'm making it equals to x and I'm making it equals to y. No. Sir said it, when you get a question on logarithms, chances are you have to convert from the index form to the logarithmic form and from the logarithmic form to the index form. Here's my question to you now. How do I convert log to the base a of b equals x into the index form? What do I write? What do I write? How do I convert log to the base a of b equals x from the logarithmic form to the index form?
Sir, a to the power x equals b.
Excellent, teacher. A to the power x is going to be equivalent to b. And similarly, log to the base a of c equivalent to y is going to be a to the y is equivalent to c, right? So I'm telling you that this is this. And you can tell me, you can draw this conclusion. I am giving you this. Then you can give me this. Because sir has taught you how to convert from the logarithmic form to the index form. And then I'm going to say to you, what if I were to multiply ax times a to the x times a to the y? If I multiply a to the x times a to the y, it must be equal to b times c, because a to the x is equal to b and a to the y equals c. Talk true.
Yes, sir.
Yeah, man. So a to the x times a to the y is going to be equivalent to b times c. But remember the law that says anytime you're multiplying and the bases are the same, we add our powers. So this is going to become now a to the x plus y. See, right, so a to the x plus y is equivalent to the same bc. But no, I am going to try and reconvert this from the index form to the logarithmic form. All about the base, about the base, about the base. The base is always the same. It doesn't change, right? You crisscross with it. So it's going to be a raised to, all right. Okay. Before I do that, let me go back to let me go back to something. Let me go back to something and show. All right. All right, I'm going to come back and talk about this little piece here that I know John Mark was asking about, but never mind. Let me do it. I don't think I should do that just yet. All right. So I'm converting now from the index form back to the logarithmic form. So I'm going to say log to the base a of bc equals x plus y. Do you agree with that?
Yes, sir.
Mhm. So all about the base, the base does not change. So if this is a to the xy, it means that the base is a, that means the logarithm has to have the same base. See here? Log to the base a, you crisscross. Log to the base a of bc is going to be equal to x plus y. See here? X plus y is going to be equivalent to log to the base a of bc. But watch it. X is log to the base a of b. So I'm going to put log to the base a of b right here, so for x. And y is log to the base of c. So see y here? I'm going to put log to the base of c. So I'm going to have log to the base a of b plus log to the base a of c is going to be equivalent to log to the base a of bc. And that's the law. Now in little school, you were told that the opposite of addition is?
Subtraction.
In logarithms, the opposite of addition is?
Multiplication.
Yes. Yes. So log to the base a of b plus log to the base a of c is going to be equal to log to the base a of b multiplied by c. No, you can't forget this. In logarithms, when you're adding, you're going to multiply. In logarithms, when you're adding, you're going to multiply. Log to the base a of b plus log to the base a of c is going to be equal to log to the base a of b times c. You notice there's only one log to the base a I have and not two. You recognize that over here, some have log to the base a and log to the base a. But over here, some just have log to the base a one time because I'm writing one of this and I multiply the 1 here by the 1 here. So the two functions are being multiplied and I'm just carrying one log to the base a. The one log to the base a going to go on both of them. So log to the base a of b plus log to the base a of c is going to be equal to log to the base a of b times c. All right, very important. Okay. Any questions to that so far?
No, sir.
Okay. Similarly, I am going to let log to the base a of b equals x, the same thing like up the front top part. And again, log to the base a of c equals y, the same thing like up top. And again, now I'm going to let therefore, converting from the logarithmic form to the index form, a to the x is equivalent to b, same thing like I have up top. A to the y is equal to c, same thing. See here, so? So this all of up here, so, is the same thing as I have all of down here, so. The exception now is that I'm not going to be multiplying my a to the x times my a to the y. I choose to divide this time. So I'm going to say a to the x divided by a to the y. So if a to the x is divided by a to the y, that means b must be divided by c. Can you see this through?
Yes, sir. Yes, sir.
Very good. So because a to the x is being divided by a to the y, it must mean that b must be divided by c. It can be that b is going to be times multiplied by c. And if you do that side here, I have to do the other side. All right. So now that I have this, and you know the law that says when I'm dividing and the bases are the same, I'm going to subtract my powers. How do you subtract, sir? It's the numerator power minus the denominator power. It's the numerator power minus the denominator power. All right. So it's going to be a to the x minus y. See here? The numerator power minus the denominator power minus the denominator power. A to the x minus y is equivalent to bc. And now I'm reconverting from my index form to my logarithmic form. It's all about the base, about the base. The base does not change. It is a to the criss and your cross. Log to the base a of b divided by c is going to be equals to x minus y. Your criss and your cross and your criss and your cross. It's all about the base, about the base. The base does not change. The base does not change. The base does not change. So it's going to be log to the base a of criss. BC is equals to cross x plus y, x minus y. But you know what x is? X is log to the base a of b. So I'm going to substitute log to the base a of b here. And you know what y is? Log to the base a of c. So I'm going to say log to the base a of b minus log to the base a of c is going to be equal to log to the base a of b over c. You notice again that I don't have two logs on this side as I do on this side. Notice again that I did not say log to the base a all over log to the base a of b all over log to the base a of c. Let me say it again. Notice I did not say log to the base a of b divided by log to the base a of c. Let me say it one last time because somebody didn't hear that. I did not say log to the base a of b all over log to the base a of c. What I said is log to the base a of b divided by c. I have just one log. It is a function that I'm dividing. So it's log to the base a of b over c. Questions? Are you okay?
Yes, sir.
No, sir.
Okay, what you're not okay with?
Sir, it's not that I'm not okay, but I'm not sure if I'm okay.
Talk to me so I can tell you, say okay.
Sir, like I'm confused.
Very confused.
I don't know, sir. Me have to try one question to know if I'm okay or not.
Okay, Talia, relax. You're fine. You're perfectly fine, Talia. You understand the first one, honey bunches?
Yes, sir.
Ah, then there is no problem with the second one. Let me show you something. And work with teacher. So you recognize that everything right up here, so in the first one is the same thing as I have right here, sir. Talk to me, Talibu.
Yes, sir.
All right, so all I'm saying to you now is, in the first example, I did a multiplication because when I'm multiplying and the bases are the same, I'm adding my powers. But in the 1 year, what I'm doing is a division. So I'm dividing my a to the x divided by a to the y. And you know the law. Let me go right up and show you. See the law here? The law says a to the m divided by a to the n is equal to a to the m minus n. It is going to be the numerator power minus the denominator power. It is the numerator power minus the denominator power. So a to the m divided by a to the n is going to be equal to a to the m minus n. Go ahead, Nati.
I understand that.
Okay, great. Great. So now you see that it's going to be a to the x minus y. If I say just understand that, but it's, and of course, this is still equals to b over c. So I'm converting that table from the index form, which is here, into the logarithmic form. I'm converting from the index form to the logarithmic form. From the index form to the logarithmic form. So it's going to be, it's all about the base, about the base, about the base. The base is always in the same position. Base, it never changes. Unless, of course, you have a different question with a different base. All right? Watch me. It is going to be log to the base a of b over c is equal to x minus y. Log to the base a of b over c is equal to x minus y. See here? Log to the base a of b over c equals to x minus y. So I'm converting this from the index form back to the logarithmic form. Right? We start off with logarithms, you know. See up here, so we start off with logarithms. And then we move from the logarithms to index, so we can see something. And then we're moving back into logarithms now. So read right here, so a log to the base a of this sum here is going to be equals to x plus y. X minus y. Why am I talking about x plus y? X minus y. X minus y. All right? And then, hold on. So similar to what I did, Natibu, up top, I am going to resubstitute the value of x. See x up here, so you're not seeing it. Log to the base a of b. So I just resubstitute x to be log to the base a of b. So right here, log to the base a of c. I'm going to resubstitute log to the base a of c right here, so right. So now I get my law to say log to the base a of b minus log to the base a of c is equal to log to the base a of b over c. See it, Natibu?
Yes, sir.
Good job. Very nice. So we looked at two laws. Log to the base a of b. What is the opposite of subtraction in logarithms?
Division.
Division.
Division, yeah man. So log to the base a of b minus log to the base a of c is equal to log to the base a of b over c. You notice what I'm saying it? I'm pausing because on the right hand side I got only one log. I have only one log. All right. So it's going to be log to the base a of b plus log to the base a of c is going to be equal to log to the base a of b times c, because I'm adding. When I'm multiplying, sorry, when I'm dividing, log to the base a of b minus log to the base a of c is going to be equal to log to the base a of b over c. Again, it's going to be equal to only one digger log. Only one digger log. All right. So we looked at technically three laws. The first law we looked at was the conversion of the index form to the logarithmic form and vice versa, the logarithm to the index. So we did some exercises on those. And now it is that you're looking at another log indices, logarithms, to say log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. When you're adding your logs, you multiply. Similarly, we are looking at the subtraction one, where log to the base a of b minus log to the base a of c is going to be equal to log to the base a of b over c. When you are subtracting your logs, you divide. And then the last diggy law for the night, before I give you a few examples to do for me, are these ones. I am going to let, okay, it is here, good. I am, all right, I can't do that. I am here, and I'm saying to you, let log to the base a of b to the n equals z. Oh, Jesus, sir. That one is different. Yeah, man. Log to the base a of b is equal to z to the n. Log to the base a of b is equal to z to the n. Sir, how does z to the n part come in? Don't worry about it. Fret not. So, log to the base a of b to the n equals z. I am going to be converting from the logarithmic form to the index form. All about the base, about the base, about the base. Log a to the z equals b to the n. A to the z equals b to the n. A to the z equals b to the n. You crisscross. All right. Now, having written that, a to the z equals b to the n, I am going to divide both sides, the powers, by n. And I'm allowed to do that. I'm going to divide the powers by n. So I'm going to have a equals a raised to the z over n, and is equals to b. A raised to the z over n, and is equals to b. So why you never divide both sides by z? Remember now, say, the a is my base. So I don't want a power right here. All right. So, ouch, whoa. So what is happening here now is that I'm going to have, when I convert this now back from the index form to the logarithmic form, I'm going to have all about the base, about the base, about the base. A to the b equals z over z to the n. log to the base a of b is equal to z over n. So this is my index form, and I'm converting my index form into the logarithmic form. So it's going to be log to the base a of b is equal to z over n. See it right here, so? And then now, is a point I'm trying to bring across, So watch me, just work with me. You may not see how to do this point, but I'm just bringing across a point. Point is, I'm going to be multiplying both sides by n. I'm going to multiply both sides by n. I'm going to have n log to the base a of b equals z. For the n, I will cancel out the n right here, so? But we're going to multiply the n right out here, so. So I'm going to be having n log to the base a of b is equivalent to z right here, so. Right in here, so. But I know that z is the same thing as log to the base a of b to the n. See it right here, so? Z is equal to log to the base a of b to the n. So what we have now is this. N log to the base a of b is going to be equal to log to the base a of b to the n. And that's the last, that's final law. Final law. Log to the base a of b to the n is equal to n log to the base a of b. Watch this orange. Log to the base a of b to the n is the same thing as n log to the base a of b. Log to the base a of b, log to the base a of b to the n is equal to n log to the base a of b. Sir, what is happening here? Notice, this is what is given on the left-hand side. Now take the n here, the one up here, sir, and just multiply it in front of this. See it right here, sir? And then we just write back everything, log to the base a of b, log to the base a of b. All right? So that's when you have a power and how to work with that power in order to get your desired answer. So with that said, John Mark, coming back to your pops. 3 to the x is equals to 5. This x is going to come in front of this, and I'm going to call it x log 3. See here, sir? X log 3 is equals to log 5. John Marcus, you have an appreciation of it now?
Yes, sir. Yes.
Right. So then, sir, why would you put a question like that right here, so I know nobody teach it? Because that was one way of me introducing this topic to you now. There's a point still that I need to bring across, but I feel guilty to ask you the pointed question. I don't feel like I want to answer the question, but there's an interesting point that comes out with these two class questions that we did. And let me tell you what is so interesting about it. This one here, I'm able to write the left-hand side and the right-hand side into the same base. This one here, I'm not, oh, come on. I'm not able to do that. I have 3 to the x equals 5, and I can't write it in the same base. Question to you is, what do I do? Aha! Sir showed you what to do. But sir, you say you have something that, like a rule or something that you're seeing, but I am not yet seeing, sir. Sir, can you tell me, please? Nope. In your own private studying, you're going to look at it, ask yourself the question, and let us see if we can come to an agreement with it. So, so 11th class. So later is here. Later is here. And let me just show you what I mean by later is here. I'm going to show you what I mean by later is here. I did the question. I don't.
Over the last one.
Last one.
Yes, sir. The last law. The Z one.
I can. I'm trying to find me something later. Give me a minute here. I'm actually trying to beef up this thing up for you. I had done a question, but I didn't put it under your stuff. So Let me just do that now. All right, so note, when you are subtracting logs, you then divide. And in this case, when you are adding logs, oh, bam, bam, bam. And in that case, when you are adding logs, ADD and NG, you multiply. MULTIPLY. All right, so let me just do this last piece here. Later is here. You remember I said to you up top, soon come on something here, so right on this thing here. We will see this a little later. So I went through here, and this is hopefully you'll be able to see what it is that I want you to pick up. Remember, I keep hinting on there's something that I want you guys to see, but I don't want to tell you. Right? So look at it here now. So I would have done this question up top here, not going to go through the question again because I did this question up top here for you just now. And I'm going to be doing the question in another form here. Right? So I'm saying log to the base a, log to the base a, log to the base 9 of 9 raised to the half power. I'm going to be using the law that says log to the base a of b to the n is going to be equal to n log to the base a of b. The same law that we just looked at. The same law that we just looked at. Just keep those eyes open for just 5 more minutes. That's all I need. And I'll let you out at 8:20. So this is a law that we just looked at. Log to the base a of b to the n is equal to n log to the base a of b. See to yourself? That one never just looked on. Sir, then why I have 2 in there? At the same thing, you know, we just write this one here so and then flip it. So n log to the base a of b is the same thing here. N log to the base a of b. And log to the base a of b to the n and the same thing here. I just write it because then equality. I write it in such a way that you can read it from either side. But it's the same thing. All right. So look at what it is that I'm saying. I'm saying to you that log to the base 9 of 9 raised to the half power would be the same thing as just calling this, putting the half in front of this and just calling it log to the base 9 of 9. And just calling it log to the base 9 of 9. So what I'm going to have is a half log to the base 9 of 9. I'm going to have a half log to the base 9 of 9. All right. And then now we need to determine the value of log to the base a of a. Right? So this is a general form. What is the value of log to the base a of a, generally speaking? So what do you mean generally speaking? It's like what I said, log to the base 9 of 9. I could ask you log to the base 10 of 10, log to the base 1 of 1, log to the base 2 of 2. So I want a general term. I don't want you to just evaluate log to the base 9 of 9 because you may not be able to follow that correlation. So what I'm trying to do now is to evaluate log to the base a of a general form of the evaluation of this. All right. So again, I'm going to let x be the unknown. Geez, sir, but all of the questions we do, sir, are the same thing. Absolutely. Thanks for asking, though. So I'm going to let x be the unknown. So I'm going to set this equals to my x. So I'm going to have log to the base a of a equals x. Converted from my logarithmic form to the index form, a to the x is equals to a. But sir, I thought you said earlier that any whole number is written to the first power. Yeah, but so you don't write it, I don't have to. But you know that a 1 is there. So since the bases are the same, I can equate my powers. So x is going to be equals to 1. X is going to be equals to 1. All right? So now if x is equals to 1, that means generally log to the base a of 9, rubbish this. Log to the base 9 of 9 is 1. Log to the base a million of a million is 1. Log to the base a number of the same number equals 1. So now I'm going to have a half times 1. A half, oh Lord Jesus, a half times 1 is going to be equals to a half. So now I'm using a different method to work the question. and still end up with the same 1/2 as I would have gotten right here. Final question. What is the difference between this method and this method down here? Anybody, somebody. What's the difference between the two methods?
So which methods?
What is the difference between the two methods? The question that I did up top and the question that I just looked at right here. Same question that I just looked at right here. Same question I just did it a different way, but I still arrived at my 1/2. I'm asking you what is the difference. If you don't see it now, it's fine enough.
So you can go back on the next question so I can see.
Sure, you move the half four.
Yeah, me move the 1/2 one. See there. Anybody, somebody, nobody?
Sir, is it that the first one you're doing it in the index form and the other one you're doing it in the logarithmic form?
All right, so I'm going to buy you a integrals.
Yes, sir.
All right, we're going to buy your integrals. You can start counting them up. Yeah. So you are on your way to unraveling this mystery. You're on your way unraveling this mystery. So yes, you are correct. But there's a second part of the question that I want you to tell me next class. What is the main difference between the two in evaluating my question? What is the difference between? So you're right. One of them dealing with indices and the other one dealing with logarithms. Your homework is that you come and have a full conversation with me. You see, I'm finished, guys. But I'm going to say to you, when we can have a conversation about the mathematics and we can speak in math language, any question the man name give you, just talk it out, no? Talk it to yourself. Just talk like you're talking to sir or to your brethren. As the same maths, at the same way it is done. So I'm going to give you, Miss G, an opportunity to look at that for your homework. I'm going to send this document off for you. And this document I'm going to send off is going to include about 15 questions. Don't worry about it. It also 3 questions a day. Yeah, those 15 questions. It is going to 3 questions a day, or 4. And since you're not going to end it tonight, and you should be good to go. I'm going to ask this question one more time. Are there any questions before we see our gentle Jesus, Michael?
Yes, sir. You can go over this one for me, please.
The last one here?
Sir.
All right. So what I'm saying to you is log to the base 9 of 9 raised to the half power is what was given as a question. So because I'm seeing, I just did a law that says log to the base a of b to the n is equal to n log to the base a of b. I see this power up here, so log to the base a of b to the n. So I can recognize this form here in this question here. But what I'm saying I must do, whenever I get a question in this form, that me just take the n and put in front of the something. Watch me. Me take the half and put in front of the something. See yourself? Put it in front of the something and then just have a log to the base 9 of 9. But the point I'm trying to make to you is that log to the base 9 of 9 is 1. Sir, how you know that? So we do the working out right here, sir. I've spent quite a bit of time in today's class and last class to show you this part. So I'm not going to show you this part again. I've spent quite a bit of time showing you. Let x be the unknown, then we write into the logarithmic form here, and then we can convert into the index form, and then you can get the value of x. All I'm saying to you now, when I evaluate this and I get log to the base 9 of 9 to be 1, it's going to be a half times 1, and it's going to be a half. So easy, we got this answer done up when we use the logarithmic form. But when we use the index form, we did it a little bit longer. But you're going to tell me the reason for that. Not now, for next class. But you should be fine. I promise you. I'm going to send out the questions. I'm going to send off the document. Remember, don't start printing it until I tell you. I added some stuff tonight. I added some stuff to the document tonight. This piece, as a matter of fact, I added just now, and I just added this piece here, so we can have a new piece of something to look at. All right, guys, 8:22. Anything else? Any other thing you want me to confirm before we go? If not, sit tight. Any questions?
No, sir.
Have a good
No.
one. Sit tight.
You too, sir.
Bye, sir.
Yes, sir. Thank you.
Bye.
Bye bye, dearest.
Bye.
Take care, guys. Good night. Bye bye.